So today we're going to learn about rock layers. We've been talking about all this crustal plate movement, things that happen because of these plates that are moving around underneath the crust, mountains, volcanoes, and things. And we've been talking about what's at the inside of the Earth, inner core, outer core. Now there's a lot of theory involved in all those things because we really don't know what's at the center of the Earth. But there's theory based on um, mathematical readings and scientific readouts from what's coming up from the mantle. But really, it is based on theory. We don't actually know what's in the center of the Earth um, because we can't test it. So I've said to some of you that the Japanese are going to be drilling down into the mantle. We're actually going to get samples of what is in the mantle. Um, However, until that happens, we don't really know what's going on in the mantle. The only thing we can actually sample and see is what's happening in the crust. So that's how we interpret Earth's history, especially in places like canyons. You can see layers and layers of rock there. So essentially, you're looking back in time by looking at a place like the Grand Canyon because there are layers of rock that have, you know, traveled and landed on top of one another. So you can see back hundreds of thousands of years in some of these places. Rock formations in the Southwest are also clues into Earth's history. So what we're going to learn today is how geologists interpret those rock layers, and we're going to take some notes, and then we're going to do a short activity interpreting rock layers and writing the geological history of those rock layers. So to begin, you'll start a new page in your notebook titled Rock Layers. You can create a 3-column chart for this, and there's not going to be a picture for every one of them, but term definition and either a picture or example. So rock layers can be seen on this cliff. This is one of those rock formations that I was talking about. Each layer represents a certain span of time. So how do we estimate the age of the rock? Now, sediments and sedimentary rocks, this is, we talked about rocks, the rock cycle. Sedimentary rocks are formed by sediments coming together and mashing together. So rock layers are sedimentary rocks because new sediment comes in, which we're going to talk about in a minute. New sediment comes in and forms each layer. So there's two types of time dating. One, this is your first vocabulary word that you're going to write on your 3-column note, relative dating. And the definition is this is what geologists use to figure out if rock is older or younger than another rock. In the example column, you can write down the older rocks are at the bottom and the younger rocks are on the top. And this is because, like I said, the sediment comes in, forms a layer, compacts down, and that's a layer of rock. Then another layer comes in, another sediment layer comes in, and then compacts down. There's another rock layer. So you could see in this is a picture of a canyon here. This lower layer existed way before this upper layer did. Something had to be the foundation for the upper layer. So this is the first, and then the second and the third, and so on. The second way, and the second term you're going to write down, that geologists figure out dating of rocks is fossils, index fossils. They're used to identify a geological time frame. They can also be used to show the approximate ages of rock. If a fossil is found in a rock, right, and that we know that creature existed in a certain time frame, then we know that rock is from that time frame as well. In your example column, just write down fossils are found only in sedimentary rocks. We talked about this in a do now. The reason why fossils can only be found in sedimentary rocks is because if you think about the way that metamorphic rocks are formed is through heat and pressure, and the way that igneous rocks are formed is through cooling magma. So both of those things are not conducive to fossils existing. Sediments, there's an animal or a plant that exists. All the sediment comes and forms around it and forms this mold around it, and then compacts, and then the mold is intact. But if this rock were to melt down into magma, that fossil wouldn't exist anymore. Same thing with like heat and pressure. If there was too much heat and pressure, all of these fossils would melt away. So sedimentary rock is the only way the only place that we would ever find fossils. So there are problems with this. Although it's, the rock layers, if they're undisturbed, this would be a great way to determine the geologic time. Fossils are a great way, but the thing is these things don't remain undisturbed. Earthquakes, faults, flooding, erosion, volcanic activity, this all happens on Earth. So we have to determine what those agents of erosions are and how they've moved the layers away. Deposition, which we're going to write down in a second. This is how sediments are deposited into an area. So if you have like a higher canyon and a lower in a valley, the deposition is going to happen in different ways. And then the earthquakes, plate movement, they cause the ground to shift. And then you have that igneous intrusion or extrusion. This is when magma seeps up from the mantle and injects itself through rock layers. So that is going to be newer than the rock layer that existed there before. So this is all the stuff that geologists have to take into account. For your notes, you're going to write down intrusion. Oops. Intrusions are formed when magma is injected into older rock layers. Okay, they must be younger than the rock they pass through, because you can't go through something unless it was there first, right? So this canyon existed, this rock wall existed, and then this magma came up through it. This magma couldn't have gone through this, couldn't have just like injected itself in here if this rock didn't exist first. For your picture or example, try to draw this just so it shows that it's kind of like, a finger that pokes its way through. Faults are our next kind. Faults cause rock layers to shift up or down. For your picture, you can just draw these little arrows. A fault is where earthquakes occur. So when an earthquake shifts the ground, sometimes the ground heaves up and part of the ground heaves down. So so that's going to change the layering of the rocks. Folds, they cause layers to bend or curve. Now you can see in this picture, you've got a lot of bend here, and the rock layers are not evenly distributed anymore. This happens if you can think about the way that the boundaries come together, convergent boundaries. When a convergent boundary presses up against each other, the rock on top of it actually folds. So you can draw that picture too, the fold of the rock. Erosion, we know that weathering breaks rocks down, erosion carries that away. And then deposition causes some layers to form faster due to sediment movement. So deposition, it's like depositing. Think about like depositing something into your bank account. Depositing means like you're putting something in. So that's when sediment comes in. But you can see on this picture, if sediment is swept into this area, it's going to layer itself here, and then layer itself some down here, and layer itself here. So these layers aren't going to have to be interpreted differently. You can also see in this picture that they've got fossils. This is a way that they can determine the layer or the age of the rock, because if sediment were to come in on top of this layer D, that same sediment came in on top of this layer A, you could still determine that the sediment that formed here is younger than A because of the fossils that exist there. Okay, so here is an intro to the activity that we're going to do. Looking at this picture, which is going to be way more cut and dry than anything a geologist sees, we go from the bottom up because, again, rock layers, the oldest are on the bottom. So going from the bottom, we can interpret the age of all of these layers. G would be first, F would be second, E would be third, And then this D and H is like the same layer. You could see that they're made of the same material. And then C goes on top. But what happened here is after these layers formed, there was a folding. Okay, these layers folded together, compressed together, and folded. Now, H and D don't connect anymore because there was also erosion. Erosion took away, if you were to just block out A and B, layers A and B for a second, you can kind of see that erosion took away this layer here. After it had folded up, you just drew a line and you could carry it along, and that would be that layer after it folded. And then erosion swept away that layer of rock all the way around. And then after that, B was deposited on top of it. So the sediment of that was deposited that created B filled in all the places that were eroded away and then settled on top to make a nice clean layer. After that, A was deposited. After A was deposited, there was some more erosion here. Okay, so A is not like that clean line that B is, because some of A was eroded away. So this is the, to interpret the age of the layers, you would say G, F, E, D, and H are the same age, C, B, A. And then talking about the geologic history, you would talk about how each of G, F, E, D, H, and C were deposited, and then there was a folding, then there was an erosion, B was then deposited, A was then deposited, and then A was eroded. So that's the geologic time or history of this rock layer. Let's do one more. For this one, there's an intrusion here. Okay, so first we have F. Again, at the bottom, this is our first rock layer. F came in, was deposited. E was deposited on top of it. Now, D is right on top of E. So this igneous intrusion came up after E was deposited and settled itself on top of E. So F deposited, E deposited, D as an igneous intrusion came up through, C deposited on top, B deposited on top of C, A deposited on top of B, and then A was eroded a little. So with this information, I want you to try this packet. Read the first page just because it kind of gives you a refresher of what we just talked about. The background information, the problem statement, and then the procedure. You're going to interpret the rock layers, the age of the rock layers, some of the lines, the relative age of rock layers, some of the lines like we did in this previous one, they might have two on one line, like D and H would be the same line. So on your second page of your sheet, you would have D and H on the same line. And then underneath, you're going to write the geologic history. That's where you're going to talk about if there was folding that occurred, erosion, any kind of igneous intrusions, and so forth. So if you have questions, as usual, let me know. We're done with our notes for now. Go ahead and get started on the activity.